This is Algebra lesson 7.3. This is scientific notation. Okay, does anybody know what is the point of scientific notation? What's the point of it? To what? Simplify what? What kind of numbers? Big numbers. Or? Big numbers or really, really small numbers, right? Like really small numbers, like way less than 1, right? You're talking about, like, atoms and molecules, and you say, well, how much of an inch is that? It's going to be way less than 1, right? So, I mean, like, you use scientific notation to make things easier to look at and read. If I gave you this number, you're like, well, how much is that number? I don't know. And then you have to start like, commas and it's 1,483,000,000,000. You know what I mean? Like, okay. Scientific notation just makes numbers easier to work with. Okay? So you need to know how to use it. You're not going to use it a lot in life, but you do need to know how to use it because this is just part of that. Okay, so the very basic rules is this. We went over this last year. I know we did because I'm about to do it with the 7th grader. So, here we go. Scientific notation. Here's the rule. This is how scientific notation is written. The first number is always what? When you're writing scientific notation, the first number is always, so it's positive. No. No. It's always between 1 and 10. It's always between 1 and 10. That is the truth. It's not 1, because if it was 1, you wouldn't need to reuse scientific notation. It would just be that number. And then it wouldn't be 10, because if it was 10, then you'd just make the scientific notation bigger, and it would just add a 0. You know what I'm saying? So anyway, it's going to be some number. So let's just say it's 2.4, or we could just say 5, or it can be 8.62084. Do you agree that all of these numbers are between 1 and 10? Right? It can be ugly, long, short, whatever, but they're between 1 and 10. And then the next thing is that it's times. Okay, it's times. And then it's 10 to the something power. Okay, it's going to be to the times 10 to the something power times 10 times 10 something. Okay, 10 to the something power. If this was going to be 2,400, then it would be 10 to the third power. Here's the deal, right? If I wanted this one here to be 0.000005, then this would be 10 to the negative 7th. We'll get to that in a second. This one here, if I wanted it to be 862,084, then it would be 10 to the 5th. This is just the way scientific notation is set up. It's some number between 1 and 10 times 10 to the something power. Make sense? Does that setup make sense? Some number between 1 and 10 times 10 to the something power. Okay, that's how you set up scientific notation. So then, let's do this. Let me take a big number here, like the number they gave is this. What number is that, by the way? 201 million. Good, you guys get that. For me to write this in scientific notation, here's the deal. Second. Here's the deal. I need to turn this number, not changing any of the numbers, but I need to turn that number into a number that's between 1 and 10. So I need to put the decimal in there somewhere to make it so that it's between 1 and 10. Where can I put the decimal here to make this giant number here somewhere between 1 and 10? After the 2, right? So I'm going to move the decimal to right here, 2.010000000. That's what I've done. I mean, that really is what I'm doing. Okay? In fact, what I need, well, we'll get to this here in a second. You don't need any of those zeros, 2.01. But what I'm going to do here is this. I now need to see. So it's going to be 2.01 times 10 to the something. Now, this is a very big number. Agreed? 201 million is a big number. When you do scientific notation, all that means is that this number here, the exponent for the 10, is going to be a positive number. If it was a very small number, if it was something that was less than 1, if it was like that 0.0000201 or something, now the exponent here would be a negative number. Does that make sense? It means it's less than 1. So anyway, this one here is a big number. So now we have to go, okay, where was the decimal originally? Wasn't it right here at the end? I'll put it in red. Don't you agree that that's where the decimal point was originally? I now had to move that baby out of there, so I need to figure out how far I have to move it. Well, I moved it 1, 2, 3, 4, 5, 6, 7. I moved it 8 spaces. Make sense? Those two numbers are identical. They're just written differently. This is called standard form, and that's called scientific notation. Does that make sense? Okay. Like I said, I know we did this last year. I know you did a little bit the year before, so this is not the first time you've seen it. Okay. What about this? I'll give you another one. Here's the number, 0.000051. Is that number between 1 and 10? No, it's not. Way smaller than 1. So we got to move it, make it so that it's between 1 and 10. Where am I going to put the decimal so that this number is between 1 and 10? Behind the 5, after the 5. Okay, so I'm going to go like this. I'm going to simply put 5.1, because that's where I'm going to move it to. How did I get it there? Well, let's take a look. I moved it from here originally to where now it goes 1, 2, 3, 4. I moved it 5 places. Do you see that? I moved it 5 places. So then it would be times 10 to the 5th. It would be negative 5, because this is a small number, right? That's a baby number. If the number we're talking about is less than 1, this is going to be a negative. If it's greater than 1, it's going to be a positive. Does that make sense? Does that make sense? Okay. Let me give you guys a couple, see if you guys can do these. This simple. Okay, try this one. 6, 8, 7, 0, 0, 0, 0, 0. 0, 0, 0, and 0.0, 2, 3, 4, 7, 2, 5. I want them both in scientific notation. Okay, because we have to do one more quick little concept after this. This number here, can you read that to me? Yeah, 68,700,000,000, right? You guys should all be good enough to know that, like these are like the hundreds, and these are the thousands, these are the millions, billions, right? Like that's something you should probably get. But anyway, that's okay. So I got to change that. Where am I going to put the decimal to make that number between 1 and 10? So 6.87. Do I need the rest of those zeros? No. In fact, that would defeat the purpose of making this smaller. Don't you agree? If I put the rest of the zeros, that would defeat the purpose. So that, okay, I go, well, it was originally here. Now I have to move it, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 10 spaces, so then the answer is times 10 to the 10th. Why the 10th? Why not a negative? It's a huge number, right? It's a big number. It's bigger than 1. Bigger than 1, positive exponent. Smaller than 1, it's less. It's a negative exponent. Okay, then down here, this thing's a baby. We know it's going to be a negative exponent, but we'll get there. How do I turn this number into something between 1 and 10? 7.25 times 10 to the, let's go figure it out. It was here, 1, 2, 3, 4, I moved it 5 spaces. 10 to the negative 5th. Negative 5th because it's a tiny number. Make sense? It's an extraordinarily big, tiny number. Right? Make sense? Okay. The other way is to reverse this. Again, this will be the other half of the 6th grade lesson here. Would be for me to give you, I'll give you one. I want you to give me both of those in, what do I want now? Standard form. I don't want you to write this as a number. Give me the real number. Okay? Okay, the first one, so we're just going in reverse order here. So we're going to take the 3.48, I put it down here, 3.48, and go, okay, it's 10 to the 6th. That means this number is a big number, right? It's big. So that means I'm going to move the decimal to the, which way would I move the decimal to make the number big? To the right, right? how many spaces am I going to move it? 6. 1, 2, 3, 4, 5, 6. My new decimal is here. The rest of these become zeros, right? So you will need to rewrite this because obviously this is a mess, but so it's going to end up being 3, 4, 8, 0, 0, 0, 0, which is 3,048,000, right? Have you got that? Does it make sense? Okay. The last one here is 2. Ooh, a 2. I don't see a decimal. What does that mean? Where's the decimal? After the 2, right? I mean, that's no big deal. So I have a 2. There's the decimal. I need to move it to the left. How many spaces? 1, 2, 3, 4, 5. There it is. I have to put the zeros in here. Rewrite it. 0.00002. How many do you have? 0.00002. Does it make sense? Negative next. Okay. Anyway, I think you guys are ready to do this part of the homework, which is going to be this. I will make it simple. Page 419, 1 through 10, all. You will do that in no problem, no time. That'll be a 5-minute lesson. Okay? But you have to do it. It's an easy 10 points. All right. You guys are out of here.